Thank you very much. Um, on the day we started unit 3, I told you we have compared risk and risk, and we have seen the elaborate introduction about the big microcontroller. And this unit you are going to study two microcontroller. One is big microcontroller and another one is ARM microprocessor. Okay, so today a comparison of risk and risk is over. Today we move on to architecture of PIC. So before going into the architecture, we will see the points, and then finally we will correlate the architecture, because directly we move on to the architecture, you can't understand. So we see the module separately, and then we will move on to the architecture. Okay, so I think these are the some applications we have discussed. The pin diagram I told you, to understand only I put the pin diagram. Pin diagram is not necessary. You have to go through architecture, addressing modes, memory organization, and registers. Okay, and instruction set. Okay, so PIC. What is the full form of PIC, ma? What is the full form of PIC?
Peripheral interface controller, ma'am.
Very good. Peripheral interface controller. Who is the manufacturer for PIC? Who is the manufacturer? Given in this man? Microchip. Yeah, very good. Microchip is the manufacturer for PIC microcontroller. And while we are comparing the earlier version, compatibility with the Motorola and Microchip, because Motorola having the um, larger number of production of microprocessor, but once Microchip come into the picture, he started producing the microcontrollers. So comparatively, the um, the the popularity as well as the market gain, visibility, everything, the Microchip company overtake the Motorola. Okay, so we will see microcontroller. We are going to see only the PIC microcontroller family. We all used to say the families of microcontrollers. So PIC, peripheral interface controller. We are going to study about PIC 16F877. Are you clear? I will once again, I will tell you the number. PIC 16. Actually, in your syllabus, they were clearly specifying PIC 16F877. What F stands for, mom? On that days, I told you what F stands for. Anyone, did you remember? F stands for what? F stands for what, mom?
Flash, ma'am.
Flash memory, ma'am.
Flash memory. Very good, very good. So F stands for flash memory. So here the PIC microcontroller, while we are starting, they have given the name. That's why they given 10, 12. It's nothing but a while moving on to one version to another version, we used to say na the same way. PIC 10, PIC 12, they have given. This is first end family, lower end, middle end, and the third family is enter into the higher end. So here we are going to 616F877. Okay, after that fourth family is that, so that PIC 17 and PIC 18 is there, but we are going to see only PIC 16F877. Okay, it's a third family of the PIC microcontroller, and it is manufactured by the Microchip technology, and the flash memory F stands for the flash memory. Okay, so before going into the PIC architecture, today we are going to see PIC architecture. In the first unit, how we have seen the architecture of the microcontroller is very, very important. The same way, the third unit, PIC architecture is also one of the important question. So here, while we are moving on to the architecture, just we will see some introduction. We all know PIC microcontroller use which architecture, ma? Harvard architecture. What is Harvard architecture? What is Harvard
Program
architecture?
memory, data memory.
Separate. Very good. Program and data memories are separate, and it supports RISC architecture also. So RISC means what? Reduced instruction set computer. How many instructions in PIC microcontroller, ma? In this PIC microcontroller, how many instructions are there? Anyone, did you remember? How many instructions I told?
35 single word
Super,
instruction.
super, ma. 35 single word instructions are there, and 8051, 255 instructions are there. So here 35 instructions only we are going to learn. So pick microcontroller having a memory. We have a RAM memory, ROM memory, stack memory is also there. Okay. Then CPU, obviously, timers and counters, analog to digital, digital to analog converter, serial communication, CCP module. I think this you have studied in DSP processor, TMS 320C2407. Did anyone remember what is CCP module? There you studied. Anyone remember? No. In
No,
sixth
ma'am.
semester, yeah. Anyone trying to tell? CCP module, capture, compare, PW model. Actually, that is not available in 8051. That's why PIC architecture is very popular in generation of signals. I told you all your kit, hardware kit has to occupy with this microcontroller because it is having a popular of generation of signal. So CCP models are there, IO ports are there, and PIC micro. Actually, here it supports only SPI I square ski UART. Okay, so PIC microcontroller, this is the main thing. It supports Harvard architecture. It supports risk uh, architecture, and obviously it having a memory organization, CPU. What is the main advantage on comparing with PIC and CCP model? That is not available. Capture, compare, PW model that is not available in 8051. Apart from that, it have a serial communication. Okay, so it's listed out what are the features I have listed out. This is with some capacity they have told it. Okay, and actually we'll directly move on to one by one. um, CPU, central processing unit. So you all know all microprocessor or microcontroller, definitely it has a CPU. Without CPU we can't able to mention it as a processor or controller. So in PIC microcontroller, what are the main thing? Definitely you understand that arithmetic logical unit, all microprocessor and microcontroller. Memory unit, you all know here we have a onboard memory is there. That's why we are specifying memory unit. Memory unit is also available in microcontroller as well as PIC microcontroller. But microprocessor we don't have a separate memory unit. Okay, in onboard memory we don't have. Control unit. Control unit, if I want to synchronize my instructions, along with that we have a control unit. Then accumulator. So the four main parts: arithmetical logical unit, memory unit, control unit, accumulator. Okay, control unit means you always know the bus means you always don't say data bus and address bus. Along with that control signals, you all know read, write are the two most important control signals. So that is also very important while I want to write the data or I want to read the data. So to that, PIC microcontroller also consisting of arithmetic logical unit. We all know arithmetic and logical unit have a capability to do the arithmetic and logical operation. So arithmetic are addition, subtraction, multiplication, division, increment, decrement, all logical na, and or exclusive or rotating instructions, swapping instructions, all will so all definite arithmetic and logical unit. If I want to manipulate any data, definitely the arithmetic and logical unit performs a important role. Okay, then memory unit. We all know while we have studied microcontroller elaborately, we have an onboard memory. So here also we have a separate memory unit. What is the advantage of on a memory unit in onboard? Now we don't need a separate memory unit to integrate. So off board, while I'm integrating for my small applications, my memory unit, onboard memory unit is sufficient to generate the program or write the program or for data, for each and everything is my memory unit is only have a capable. So I don't need a separate memory unit. So the cost of the system is get reduced and the complexity of the program is also reduced. Okay, then control unit. I told you the timing and control signals are very very important. So read, write operations, everything should be synchronized with my clock. Then only my data will, while am I transferring my data from memory to processor controller or controller to processor, whatever that, or to export the data or import the data, the control unit is very important. Then accumulator, I told you, all processor, whether it whatever may be the processor, accumulator is the primary register. So depending upon the length of the microcontroller, if it is 8 bit, micro accumulator is also 8 bit. If it is 16 bit, now accumulator is also 16 bit. So you all understand, CPU, micro microcontroller, pick microcontroller having ALU, memory unit, control unit, accumulator. Okay. Then memory organization, actually it's a one of the important topic. Actually I'm not going to separately going to see the memory organization, even it is given in the syllabus. The pic 16F877, that itself, architecture itself covers the memory organization. Okay. So I think there is a light, I don't know why. Okay. Pick memory organization. We have a three memories are there. Okay. We always used to say program memory and data memory. Okay. Here also we have a program memory and data memory. But program memory is also flash memory. Data memory is a RAM memory type. Flash memory, um, we used to say it's a non-volatile memory. What is non-volatile memory, ma? When the information is will be stored, even the power is turned off. So program memory and data EEPROM memory are both are non-volatile memory, but my data memory is a RAM memory type. Okay. Okay, random access memory type. And EEPROM, electrically erasable programmable read only memory. Okay. So I have given EEPROM full form, electrically erasable programmable read only memory. So we all have to understand that we have program memory with ROM, data memory with RAM, and data EEPROM, that is nothing but we have these two are non-volatile memory. Okay. And this data memory is a RAM type, so it's not a non-volatile memory. So obviously what happened now, if there is I want to save the data, the power should be maintained, otherwise my data will be uh, my data will not be saved in the particular memory. Okay. So we have program memory, data memory, data EEPROM memory. So three memories are there. You have to understand: program memory, data memory, data EEPROM memory. Actually, we are going to discuss this in detail to understand that. So pick having that's we in pick we have started. We are saying RAM memory is there, ROM memory is there, then stack memory is also there. So first we will discuss about program memory. I think you can able to view that what is my program memory capacity. 8K, actually in onboard chip, what is the capacity, ma? 8K word. Okay, you just see this figure. My program memory starts from 0000 to 1FFFF. So you have to understand that. Can you able to see this, ma? This is on chip memory. What is the capacity of that on chip memory, ma? There we have seen only 4K capacity. Did you remember? 8051 microcontroller having only 4K memory capacity, but here on chip memory is 8K memory capacity. So my memory will vary from 0000 to 1FFF. So you all know 1FFF now, that is in hexadecimal value. If I convert into decimal value, my value will be 8191. So how many locations were there, ma? 8191 locations are there. That's why I'm specifying it is 8 kilobytes memory. 8 kilobyte memory. So in that 004, I can write ISR. What is ISR, ma? Anyone tell what is ISR? What is ISR, ma? Yeah.
Interrupt service routine.
Yeah, very good, Kodishwari. Interrupt service routine, ISR is nothing but interrupt. So if I want to write any interrupt service routine program, I will write it in which memory, ma? 004. You all understand, this is page 0, page 1, page 2, page 3. Can you understand or not? So my page 0 will vary from 0002 07FF. Okay, actually, this is they allocated for interrupt service. Then page 1 capacity is 080002 0FFFF. Then page 2 capacity is 1002 17FF. And page 3 capacity is 18002 1FF. So you can understand that each page having 2 kilobytes. So totally we having 4 page. So 4 pages now 2K into 4, the total capacity is 8 kilobyte is my onboard memory capacity. So 8 kilobytes, they said 14 words. So 14 words now, you just see how I will write now. I'm sorry. Okay. One, sorry, I think 1 F F F. 1 FF now will you write ma? 1 F 11111 11111 11111. Are you clear ma? So totally they allocated, you just see, 4 8 12. Okay, but here we have only one. So what they are saying now, 13-bit program counter capable of addressing 8K word and 14-bit program memory space. Actually, 13-bit is sufficient because how many fours are there? How many F are there, ma? 3 Fs are there. Each F is I can I can denote by 4-bit. So 4 into 4 into 4. So totally 12. So apart from that, we have one. So totally how many bits, ma? 13 bits. So what we say, 13-bit program counter. Actually, 13-bit is enough, but it have a 14-bit program memory space will be there. So here, now I will discard it. Okay. So here you can just see they have given how many ma? 13-bit. Have you seen the slash denotes? It's a length of the bus. Have you understand? So the slash denotes 13. So 13-bit. So 13-bit program counter. And how many? What is the on-chip memory capacity ma? 8 kilobytes. 8 kilobytes on chip. Okay, I told you here. Here RAM memory will be there. ROM memory will be there. Stack memory is also there. So here we have seen how many stack ma? Stack level 1, stack level 2. So how many stack? 8 deep level of stacks are there. So what is the advantage of 8 deep level of stack now? My stack can store 8 stored. If I push any data in my stack, it will store 8 data. Further, if I'm importing the ninth data into my stack now, what happen? It will erase the first data and it will store it there. If I'm importing the 10th data now, it will erase the second level of deep and it will store the data. But my stack can store 8 level of stack can be stored. 8 deep level of stack will be there. Can you understand? And you have seen call return. Where we you use call return ma? Where we have a call and return instructions. Call and return. How many?
Delay program
Yeah,
it ma'am.
subroutine. Call is mainly used for subroutine.
Subroutine to
Return
main.
return return
Subroutine
from
to main.
subroutine to main. Okay, so actually this is a return from right and read that we separate. So you have to understand call and return first. So here you have mentioned na program counter 0 to 12. 0 to 12 na how many bits ma? 13 bits. Why? 1 FF is the my maximum um, memory space address. So FF now 12 plus 1 13 bit. So you have to understand that my program memory is divided into pages. How many pages are there? 4 pages are there. Each page is having 2 kilobytes. So totally 8 kilobytes. It's a 13-bit program counter and stack is there. How many deep level of stack? 8 deep level of stack. And especially for interrupt vector, this is 004. So 004 is they allocated for the ISR routine. Okay, so this program having what is the advantage? I told you this program having what is the advantage? I already told what is the main advantage now? Each time we burn program into the micro, we can erase an old program and then write a new one. That is the main advantage on this big microcontroller. That is why it is very popular on generating the pulses, because the cost is also low. One, while I am purchasing one big microcontroller chip itself, I can program it, I can fuse my program through the macro. We have seen Kale compiler and all now. So what we do, we will write the program in Kale compiler. After writing the program in Kale compiler, sorry, after writing the program in Kale compiler, so what we can do, if I want to erase, I can erase, and I can um erase my old program, and I can burn my, and I can write my new program. That's why I told you all these are EEPROM type. Okay, it's not a ROM type. In microcontroller we don't have a onboard memory, we can't able to erase any memory. That's why we have an external memory with a capacity of 64 kilobytes are there. External is also, if I can interface, but here we have a capacity. So any new program I can able to write, or if I want to erase any old program, that also I can able to do. Okay, so that's all about whatever I told you na, the staction circular buffer. So circular buffer na, it can able to push 8 times. If ninth push over right now, it will, what happen, it will remove the first push. So if I want to write the 10th push now, it will remove the second push. Okay, so that's about the stack operation. And I told you ISR, interrupt service routine. Okay, that will be stored in this address 004. So program control is 8 level deep uh, stack will be there, 13 bit wide. We have seen that, and the capacity is 8 kilobytes onboard memory. That's the point listed out here. Okay, so first memory, we have got three memories are there: program memory, data memory, data EEPROM memory. Three memories are there. So program memory we have completed. The next we are going to see will be the data memory. So here you understand, the program memory will be in the pages. You are seeing program memory is divided into the pages where the program is stored. But when you see data memory it will be in the form of banks. We already see now in 8051 we have a bank like structure. So all the registers will be stored in banks. So here also we have a bank structure is there. So how the 2 bits they are allocated for banking, RP1 and RP0. So if it is 00 na, bank 0 will be selected. 01 na, bank 1 will be selected. 10 bank 2, 11 bank 3. So we have a four banks will be there. Or you understand, we have a four banks. So here definitely we have a general purpose registers as well as special function registers will be there. So previously we have seen a special function registers now, the register particularly will be used for like serial ports, like timers, and for ports we have seen that are the from special function register. So here also we have a general purpose as well as special function registers. So we have a four banks. Four banks are there: bank 0, bank 1, bank 2, bank 3, and each bank having 128 bytes of addressable memory. Okay, so there how many bytes we have seen, ma? In 8051, how many bytes we have seen? How many bytes we have seen, ma? 8051 RAM capacity, how many bytes? 8051 RAM, how many? What is the capacity of RAM in 8051, ma?
256.
256 bytes are
2
there.
KB.
Very good. 256 bytes are there. But what we used to save there now, there are also banks. Four banks will be there. Each bank having a capacity of 8 registers are there. But here you see, each bank capacity is what more? 120 by 8 bytes. There each bank can store only 8 registers. So totally we can able to store 32 registers. But here each bank having the capacity of 128 bytes. I think you can see that. Okay, so this is my bank. Can you understand? So this is 128 bytes, 00 to 7f, 128, and again 128, 128, 128. So 128 into 4, so 128 bytes. So each bank separate, so nearly 512 bytes will be there. That will vary from microcontroller to microcontroller, because PIC16 of 877 having 4 bank, each bank having the capacity of 128 bytes. Are you clear, ma? You have seen these are the general purpose registers, and these are the various registers. Don't worry on that. While we are discussing about direct and indirect addressing, I will explain you what are all the things, this and all. So you just see, to understand purpose only I have put it this. So we have a status registers, port registers, TRI stress register. Okay, what the status register will do now? It will change a move between the banks. Port registers, we all know what is the purpose of port register. Na? We will assign 0 or to 1, and if I want to interface any devices through port, we will interface. So whether it will act as an input port or output port, the same way the port registers will serve. TRI, the data direction registers. Okay, but you have to understand, data memory means here data memory will be in organization, will be in the form of bank, each bank having the capacity of 128 bytes. So totally 4 banks are there. Okay, this I told you. General purpose registers, special function registers. General purpose registers now, it don't have any special function. What it will do, it will use to perform any arithmetical and logical operation only. I can be able to access my data through this general purpose register. Special function registers, special function registers is not that. It will specifically used for some special function, like ports or communication, serial communication registers, timer registers, or special functions. It is dedicatedly used for that particular function only. The manufacturer itself will import the functions for that register. We cannot able to change the functions of that special function registers. Okay, the third memory is data EEPROM memory. I told you, data RAM memory is there, data EEPROM is there. So EEPROM, electrically erasable programmable read only memory. So EEPROM memory means, what is the advantage, ma? I can do read operation as well as write operation. Mainly when it things are here, I can do single word read, the flash memory, but 4 word block write I can do. Single word I can read, at the same time I can write 4 word write also possible. So depending upon the full voltage range only, this data EEPROM will be there. So some special function registers are there. I told you, all SFR register we will discuss separately, but this EEPROM, data EEPROM have a 6 special function registers for read and write operation only. EECON1, EECON2, EE data. So to we will discuss separately, but you have to understand that my data EEPROM have a reading as well as writing operations, as well as I can capable of operate with my 6 EEPROM registers are there. So we will discuss while I'll discussing with the register organization. Okay, then. So first what we discussed, ma? What are all the things we have seen in PIC microcontroller? First we have seen with CPU, central processing unit. The next we have seen memory organization. So the third part is serial communication. Okay, in 8051, what kind of serial communication we have seen, ma? In 8051, it offers which serial communication? All went to which mode? Sleep mode. Ragulkar? Ragulkar. Register number 66, Ragulkar. Ragulkar. Hmm. So you people are not have a continuous listening of class. Ragulkar. We come and say network issue. Jerson. 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 No.
Yes, ma'am.
Who is saying yes, ma'am? Jersana.
Yes, ma'am.
Yeah.
39.
39, Jason. Jason, tell me, in 8051, What type of serial communication protocol we used? Answer is here only. What type of serial communication protocol we used in 8051?
Yes,
Huh?
SPI protocol.
SPI protocol. Ah? Oh, protocol is there. You will read it. Ah. No, man. SPI protocol today only. You people are going to hear this word. You are saying SPI protocol. Huh? Which protocol? Then another one you will read it. Ah.
Nothing, no, no, no.
You don't know. So you are not listening. You people are not. Ragulkar went somewhere else. Switch on his attendance, and he will. When attendance will comes, he will come and give the answer. Shanmuka, which protocol we used in your 8051 serial communication, ma? Shanmuka,
Ma'am,
tell me. Which serial communication protocol we used in 8051? Very tough question. Oh my
12C
god.
protocol,
Huh?
ma'am.
Which protocol? I can't able to hear.
12C protocol.
Huh? Oh my god, I need answer. Please, anyone tell.
Synchronous and asynchronous.
Universal synchronous and
Ah,
asynchronous receiver and transmitter.
UART, Universal Asynchronous and Receiver and Transmitter. Even I can't say. UART. Here also USART. It supports both synchronous and asynchronous. I have told you UART. Universal Asynchronous Receiver and Transmitter. 4 modes of operation I have explained you. Shift register, 8-bit UART, 9-bit UART, 9-bit UART, mode 0, mode 1, mode 2, mode 3. I've taken nearly 1 hour of serial communication in 8051. I'm simply asking which protocol we have used in 8051. Everyone is saying SPI protocol, I2C protocol. Did you hear this word earlierly? Earlier I said before that, while I'm giving introduction about the embedded system only, I told you. I never opened about this protocol while I'm teaching about 8051. How you people are listening, ma? And frequently I'm conducting the quiz also. Weekly 2 quizzes you are attending. But I asked now simple question. Shanmuga, you're not listening. I thought you can able to answer. That's why the question is shoot up to you.
No, ma'am.
Very poor. Okay, listen. At least what I'm saying. See, uh, everything will look similar only. That's why I'm repeating the point. Keep on. I'm repeating. I'm saying this point. So in PIC microcontroller, it offers 3 protocols in serial communication. There in 8051, it offers only one. That is UART, Universal Asynchronous Receiver and Transmitter. But here USART, Universal Synchronous and Asynchronous Receiver and Transmitter. Serial Peripheral Interface Protocol, I2C, Inter-Integrated Circuits Protocol. You all understand that universal synchronous asynchronous receiver and transmitter, we all know we have a full duplex mode of communication or half duplex and all. So here in this protocol, transmitted and received bit by bit through a single wire according to the clock pulses. So to send and receive data serially, the PIC microcontroller has 2 pins, receiving and as well as transmitting. So TXT and RXT. So if I want to transmit any data, I will enable my transmit pin. If I want to receive any data, I will enable my receiving pin. So there we use the one buffer, serial buffer register. Did you remember? I told you the serial buffer register will hold the data. It will use to transmit as well as it is going to receive. Then next one is SPI protocol, serial peripheral interface. So you all understand that it is used to send between two PIC microcontroller or any other peripheral devices like sensors, shift register, and SD cards and all. So SPI protocol, serial peripheral interface protocol. You all understand the communication protocol is very very important, because if I am what communicating, that has to be enabled to according to the sensor, according to the communication data it is receiving, it has to react. So even I told you in automobile, this SPI protocol, then another one is CAN protocol is very very popular, while to communicate between each and every devices, the protocols or communication protocols is very very important. So here, if I want to send the data between the microcontroller or between the sensors or shift register or SDI card, SPI protocol is there. This is a 3-wire SPI communication is there. Okay, so mainly SPI protocol has a comparing greater data capability than USART. We all know USART is working baud rate. Baud rate now, maximum we have seen 9600 baud rate will be there. Bits per second will be transmitted. But SPI protocol having greater data capability than USART. So that is the main advantage in the PIC microcontroller rather than the 8051. It's one of the big advantage. Okay. Then I2C. I2C means inter-integrated circuits protocol. So this is used to connect very low speed devices like microcontroller or some other memory devices, EEPROMs, analog to digital converters and all. This will used, but this will support 2-wire interface. Okay, so mainly this will work as an master slave devices. Okay, so you have seen this. My PIC microcontroller having a TX and RX. You have seen that max 232 cable. Actually, this you will study in detail how it is transmitting and all in your 4th unit. Okay, all the protocols, serial communication protocol, you will study in detail. That's why I'm not touching the protocol in such. You have to know what are the serial communication is adopted in PIC. USART, SPI, I2C. USART na universal synchronous asynchronous receiver and transmitter. Serial peripheral interface SPI. I2C integrated circuits. Okay. The next one is 4th, interrupts. Here, how many interrupts are there, ma? 20 interrupts are there. There, how many interrupts are there? Anyone tell, ma? How many interrupts were in 8051 microcontroller?
5, ma'am.
Very
5,
good.
ma'am.
Five interrupts are there, but here we have a 20 internal interrupts are there, and 3 external interrupts also there. So mainly this interrupts are mainly used to relate with if I want to do communication or I want to convert my data analog to digital, timers, capture, compare, PW model and all we will use. Okay, then timers. Now we will enter into the timers. So here, there how many timers we have studied, ma? There how many timers are there? How
2,
many?
ma'am.
Very good. 2 timers are there. But here, how many timers are there, ma?
3, ma'am.
3 timers are there. Very good. Timer 0, timer 1, timer 2. Okay, there 2 timers are there. 2 timers are 16 bits timers. But here, what you are saying, timer 0 and timer 2 are 8 bits. Timer 1 is 16 bit. You may ask how it they are there. These are all designed by microchip technology. We are going to learn how many timers are there and we can how we can name it. Okay, so 3 timers are there: timer 0, timer 1, timer 2. So timer 0 8 bit, timer 1, timer 2 is also 8 bit, timer 1 is only 16 bit timer, and timer 2 especially they will used in the CCP, capture, compare, PW model. Okay, then CCP model, I have told you, CCP model, capture, compare, PWM model. You may have one doubt, what is capture, compare, PW model? Okay, actually, sure. Can you able to see this white screen, ma? Is it visible? Okay, actually you have studied there, you just understand. This is my sawtooth gel. Well, okay, okay, actually, okay, I'm drawing one sawtooth waveform. You all understand? This is my sawtooth waveform. Okay, and here there is one we have studied carrier wave and reference wave is there. So this is my carrier wave. Okay, and this is my reference wave. Okay, so here what happened now? Every time if I compare, when the value is equal, what happened? It will generate the waveform. This is my PWM pulses. Are you clear? So capture, compare, PW model. It's nothing but generating of signals, compare, and it will produce the PWM pulse. So CCP module, it's not available in microcontroller. 8051 microcontroller, we don't have a CCP model. That's why 8051 microcontroller is not popular in any way. This will be very popular. Oh my God. Students, can you able to see the screen, ma? Net cut ஆயிடுச்சா? No, no. என்ன இல்ல glow ஆகல. Students, is it visible, ma?